In this question, a statistically determinate frame is given to us, which can be seen here. And the internal forces at arbitrary distances from point A and from point B are required to be determined. So we named this first distance x1 and the second one x2, and we're going to cut the frame from these two distances and then determine the internal forces at these two distances. We're going to start solving this question by writing the equations of equilibrium for the whole structure, determine the reaction forces at A and C, and then we're going to calculate the internal forces at the required distances. So this is our frame. We have AY here, we have CX here, and we have CY here. We can start by writing sigma Fx is equal to 0. The only force in the x direction is Cx. So Cx plus 0 is equal to 0, which gives us Cx equal to 0. In the y direction, we can write AY plus CY minus this 3.2 multiplied by 2 meter, which gives us a point load of 8 kilonewton at a distance of 1.25 meter. So this will be equal to 0. So AY plus CY is equal to 8. And finally, if we take the moments about point C, we can write sigma MC equal to 0 in this direction. So AY multiplied by this distance, which is 4 meters, minus 8 multiplied by 1.25 is equal to 0. So AY will be equal to 2.5 kilonewton. And now if we put this AY in this equation, we have 2.5 plus CY is equal to 8, and this will give us CY equal to 5.5 kilonewton. So this is 2.5 kilonewton, this was 0, and this was 5.5 kilonewton. Now let's cut the AB section from an arbitrary distance of x1. This is our V1, this is our F1, and this is our M1, and this was 2.5 kN. Now if we write the components of this force in this direction and in this direction, so it will be like this. This will be AX, this will be AY. AX is equal to 2.5 cosine of this angle, and AY will be 2.5 sine of alpha. So this is our alpha. This was 1.5 meter. This was 2 meter. This is 2 meter. This is 1.5. This length would be square root of 1.5 in the power of 2 plus 2 in the power of 2, which is 2.5 meters. Cosine of alpha is 2 over 2.5, which is 0.8. And sine of alpha would be 1.5 over 2.5, which is 0.6. This is sine of alpha. So this is equal to 2 kn, and this is equal to 1.5 kn. 2.5, this is 1.5. And if we write sigma fx in this direction, so f1 plus 2.5 is equal to 0. So f1 is equal to minus 2.5 kn. Or we can write f1 is equal to 2.5 kn in this direction, which means that the member is in compression. In the y direction, we have 1.5 minus v1 is equal to 0, so v1 is equal to 1.5 in this direction. Sigma m at x, which is this point, equal to 0. So 1.5 multiplied by x1 minus m1 is equal to 0. So m1 is equal to 1.5 x1 in this direction. So this is our x2. This is 2.5 meters. So this length would be 2.5 minus x2. And we have 2.5 minus x2. This is v2, this is f2, and this is m2. Sigma fx equal to 0 this direction. So minus f2 plus 0, since there's no other forces in the x direction, is equal to 0. So f2 will be equal to 0. So in order to determine v2, we're going to calculate the value of this point load, which is 3.2 multiplied by this distance, 2.5 minus x2, or 8 minus 3.2 multiplied by x2 actually. So we have sigma fy equal to 0, v2 minus 8 minus 3.2x plus 5.5 is equal to 0. So v2 is equal to 2.5 minus 3.2x2 in this direction. And finally for m2, if we name this point x2, sigma m x2 is equal to 0. So 8 minus 3.2x2 multiplied by this distance, which is 2.5 minus x2 divided by 2, minus 5.5 multiplied by 2.5 minus x2 plus m2 is equal to 0. This will give us an m2 equal to minus 1.6 x2 in the power of 2 plus 2.5 x2 plus 3.75 in this direction. So we determined the reaction forces Cx AY, CY, and we determine the internal forces at any arbitrary distance from point A. So F1 is always equal to 2.5 no matter what the x1 distance is. V1 is also equal to 1.5, and M1 is 1.5 multiplied by x1. And at any distance of x2 from point B, we have F2 equal to 0, V2 equal to 2.5 minus 3.2 x2. And this is the equation for M2. That's it. Please subscribe to our channel if you haven't already. And please like this post if you liked it. And feel free to write your comments below if you have any suggestions. Thanks.